In this video, we'll be going over search and rotated sorted array 2. So this is an integer array num sorted in a non-decreasing order, not necessarily with distinct values. This means there are duplicate values inside the array. Before being passed to a function, nums is rotated at an unknown pivot index. This means the input array will be sorted and rotated at the same time. So given the array nums, after the rotation and an integer target, return true if target is inside nums, or return false if it's not inside nums. So for example, we can see that the array is sorted in ascending order 0, 0, 1, 2, 2, 5, 6, but it's rotated around here. And we're trying to find the target. And since 0 is inside the input array, we're going to return true. Let's go over the thought process. The brute force approach will be to perform a single iteration through the input array. This approach will cost us of n time complexity. We should note that we are searching inside a sorted and rotated array. When searching inside a sorted array, the optimized approach is to use binary search. We just need to handle the rotated portion. The rotated portion of the input array. So let's go over the binary search thought process. Let's have three boundaries, or three pointers, currently at left, mid, and right, which is a binary search. And we're currently at mid. If nums mid is greater than nums left, this means the left side is sorted in ascending order. If target is within this range, we will be searching leftward. If not, we can just search rightward. Then if nums mid is less than nums right, this means the right side is sorted in ascending order. Then if our target element is in between these two indices, we can search to the rightward. Else this means our mid is going to be the same as the one on our left side and also on our right side. This means we will need to search one side first. We will search left first. If we have failed to find the target on the left side, we'll continue our search rightward. We'll first search leftward. If we have failed to find the target, we will search rightward. Let's go over the pseudocode. So we're going to implement the binary search approach. We're going to implement a recursive binary search approach. And then what parameters do we need? First, we'll need the left pointer, which is initially 0. And then right, the right pointer, initially at the end of the array. And then our nums, the input array. And target, the input target. And then what's the base case? If left is greater than right, this means there are no elements left. Then we have failed to find the target elements, so we can return false. Then in each of the recursive call, we will first calculate the mid index. So calculate mid. We have mid is equal to left plus y minus left divided by 2, which means exactly at the center. Then if nums at mid is equal to target, then we can return true. We have found our target elements, so we can return true. Then we'll first check if our left side is sorted in ascending order. So if nums left is less than or equal to, is less than nums mid, this means the left side is sorted. Then if target is within range from nums left to nums right, nums left to nums mid, we will return the recursive results of searching leftward. So we have mid, we have our right side, our right boundary turned to mid -1 because we're searching rightward. Else, this means it's not within the range on the left side. Then we will search our right side. So we can return the recursive result of searching rightward. This means sending our left to mid plus 1. Now else if num's mid is less than num's right, this means the right side sorted. Then we have to check. If target is within the range from num's mid and num's right, this means we can search rightward. Then we can return the recursive result of searching rightward. And then else, we want to search leftward. So we're going to return the recursive result of searching leftward. Then else, this means we have found, we do not know if the left side sorted or the right side sorted. So we have to search one side first. So we're going to recursively search the right side first. The left side first. Left side first. Then if the recursive result is true, then we can just return true. Else we need to search our right side. So we can say return the recursive results of searching right side, which is left equal to mid plus 1. Now let's go over the time and space complexity. Time complexity, there are two cases. One's the average case and one's the worst case. So the average case is log of n, where n is the length of the input array. We have log of n because of binary search. And then we have worst case of n because of this. Because we may need to search both left side and right side, which may incur of n. And then our space complexity is also two cases. So the first one is the recursive call stack memory. Call stack memory. And the worst case, we have a recursive call stack memory of O(n) when we're searching both left side and right side. Let's go over the code. So we're going to implement our recursive binary search. Our current left and right boundaries. And then our input array and our target. Left, int, right, input elements, and the input target. If left is greater than right, there are no more elements left, so we're going to return false. And then we calculate the mid index. And then if num's at the mid is equal to target, we have found our target elements, so we can return true. And then if num's left is less than num's mid, this means the left side sorted. That means if target is within the range of num's left and num's mid, we can search leftward. So if num's left is less than or equal to target, and target is less than num's mid, we're going to return the recursive results of searching leftward. We can search leftward, so left is mid minus 1, nums, and target. Else we want to return the recursive results of searching rightward. So it's going to be mid plus 1, right. And then we're going to check if num's mid is less than num's right. This means the right side is sorted in ascending order. And then we want to check if target is within num's mid and num's right. So if num's mid is less than target and target is less than num's right, we want to return the recursive results of searching rightward. Else we will search leftward. And then else we will need to search both sides, but we will search one side first. So we'll first return the solution of searching leftward. So let's first search leftward. Is this? If this is true, then we can return true. Else we want to return the recursive results of searching rightward, which is mid. The searching rightward. Target less than or equal to nums right. Let me know if you have any questions in the comment section below. Like and subscribe for more videos that will help you pass the technical interview.